calculus students. So we're going to do 2.4 right now. And the objectives for this is we are going to learn about the chain rule. So we're going to use the chain rule when taking derivatives. Okay? So what is this chain rule? It's basically when you see a function inside of a function, so you have some composite functions going on, then the way I think of that is kind of like the inside function and then the outside function. So it's kind of when you see two functions inside of each other. And for this is kind of the harder one to understand. But basically what you're going to do is you're going to just cover up the inside function, look at the outside function, and take the derivative of the outside, leaving the inside alone, and then multiply by the derivative of the inside function. So take the derivative of the outside, leave the inside alone, okay, and then multiply by the derivative of the inside. Okay? And that's what this is saying too. See how that's left alone? So take the derivative of the outside, leave the inside alone, times then the derivative of that inside. Okay, so let's look at this one. We're going to find the derivative of this guy. So here dy dx, this is my inside function, and my outside is basically just kind of like, so my outside function would kind of be like x to the fourth. And then the inside of that x is the x cubed plus 6. So I'm going to cover this up, take the derivative of the outside, so I bring the 4 down, leave the inside alone. So bring my 4 down and subtract 1. Then multiply by the derivative of that inside. So let's see, that'd be 3x squared and then plus 0. And we can reduce that now. Okay, on number 2, I could make it a quotient and a chain rule, or I could just rewrite what this guy's going to be by bringing up that exponent, and now all I have is a chain rule. So dy dx, that's just a coefficient. What does it do? Woohoo! Goes along for the ride. So I'm just going to bring that down. Okay, so now here is the function that I have to take the derivative of. So I'm going to bring my negative 5, leave the inside alone, subtract 1. Then times the derivative of the inside. And again, I can reduce that a little bit. So let's see. 15 times negative 2 is negative 30, and then the x. I'm going to bring that negative exponent down. And there we go. Okay, now for this next one, 23, I definitely have to have two functions. I cannot rewrite this any other way than with the two functions. So as I'm dealing with this, I'm going to have that, and I'm going to have, and I'm just rewriting it, that. So I will have a product, and within the product, I'm going to have a chain. So this is my first, and this is my second. In the second, this is my inside, and that's the outside. Okay? Okay, let's take our time. So for the product rule, I'm going to take my first times the derivative of my second derivative of the outside, leave the inside alone, times the derivative of the inside, plus my second times the derivative of the first. Now we got to clean all that up. Simplify that. Alright, so let's see. Those, I can cancel 1, 2 with 1 1/2, so that would be what? Negative 1/2 x cubed. And I have my 16 minus x squared to the negative 1/2. Plus, that's nice, those cancel. So I have x times 16 minus x squared to the positive 1/2. And if you remember, back in chapter 1, we learned how to simplify these as well. So I'm going to take out a negative 1/2 x and the 16 minus x squared to the negative 1/2. So then what do I have left? I have an x squared minus 2 times 16 minus x squared now to the first. So real quick, that's going to be x squared minus, excuse me, 32 plus 2x squared when I put that together. So let's see, I'm going to have that x still up there, the 2 down here, the 16 minus x squared to the 1/2 now. And then that guy all became x squared, 3x squared, sorry, 3x squared minus 32. Okay? I feel like I left off the negative, didn't I? I did, right there. Oh, okay, there we go. Forgot to bring my little negatives down. Ah! Okay, so now that's good. Yay! Okay. Yay! Look at this one. We have the inside and the outside. But in the inside, we have a quotient rule. So when we do the derivative of that inside, we are going to be doing a quotient rule. So the derivative is a quotient. Don't make fun of my spelling. Rule. Okay, so let's see. G, so I'm going to be taking g prime of x. Okay, derivative of the outside. Leave the inside alone. Subtract the 1. Now times the derivative of the inside, and this is when I'm going to do my quotient rule, when I do the derivative of the inside. So low, d high, minus high, d low, all over low, low. And let's clean this up a bit. So I'm going to distribute right here. 12x squared plus 18x minus 6x squared plus 4. And then down here I'm going to have that 2, so they're squared and they're squared, so that's going to give me 4 of those. And I can clean that up a little bit. And there you go. Actually, I think I can do a little bit more. I could pull out a 2 here and make that a 6. So let's just go ahead. Let's do that. Again, I'm going to make that a 6. So let's see, can I factor this guy? A times C, whose sum is B. So anything that multiplies to 6 and adds to 9, nope, so that's prime. So that's as far as I could go. Okay. Woo, we got some trig. Aren't you glad we don't have to do the limit rule? So here is my outside, and here is my inside. So the outside is the box, the inside was the circle. And what does that 4 do? Woo! Goes along for the ride. Okay, so I'm going to take the derivative of the outside, leave the inside alone. Well, derivative of secant is secant u tan u, and your u in this case is 8x. So it's going to say secant 8x tan 8x. And then the derivative of the inside here is 8. There you go. Okay, number 6, I'm going to rewrite this just a little bit before I begin. So I'm just going to distribute that square so I can see this a little bit easier. So that's pi squared x squared. So now I can break this apart into 2 different things since it's a plus or a minus. And then over here I have my inside and I have my outside. And the 5 goes along for the ride. So my dy dx is going to equal derivative of 3x is 3, minus 5 goes along for the ride. The derivative of the outside is a negative sign, leave the inside alone, times now the derivative of the inside. Well, pi squared is just a coefficient, so it goes along for the ride, times 2x. Clean that up for sure. So I'm going to bring those with that. Negative, negative makes it a positive. 10 pi squared x times my sine of pi squared x squared. Okay, I hope that you pause me at some point and try to do number 7 on your own, and then unpause and check with what I get. So here I'm going to take g prime of x. Cosine, here let's rewrite this first. Cosine squared is the same as saying cosine here of the pi t all squared. Okay, so here's my inside. There's my outside. So 5 times 2 is 10. Leave the inside alone. Now that becomes to the first power times the derivative of the inside. Well, the derivative of cosine is negative sine. Leave the inside alone. But wait, now times the derivative of the inside again, which is pi.